I started it. Fine. So I think we are a pretty small group. Actually, we were actually expecting more persons to join, but since it's a pretty small group, we can actually start introducing yourself. Just a matter of 1 minute, just to say your name and what you are actually doing right now, so that I will get an idea regarding what all things you may be expecting from the session, what is your technical expertise, and I think I can start from, I think I can see this participant list. Nagaraj, can you just introduce yourself, please? If you have the mic.
Good morning.
Morning.
I am Nagaraj Biradar, working for Mangalore Chemicals and Fertilizers Limited.
Okay, okay. Are you into IT infrastructure or?
No, I am basically into marketing department. Just I want to know about the data center virtualization. For that, I have joined the class.
Yep. Great,
Yeah.
great.
Thank
You
you.
are welcome.
Thank you.
So, who is next? Indumati. Do you have any mic? I can see that you have. Maybe you can chat it. If you don't have a mic, you can chat. Ratish, can you introduce yourself?
Hi guys, myself Ratish, and I'm calling from Melbourne, Australia. I've got this invitation via LinkedIn, so I thought, to get an understanding on data center virtualization, I'll join the session. Basically, my profile is into data center and service provider environment. I play a role of network consulting engineer.
Okay. Yep.
Here in Melbourne. Thank you.
Hope you are already familiar with the virtualization also, right?
Yeah, I know some virtualization concept, but I thought what's interesting and what's new in the market.
Yep, yep. So, who is next? If everybody there, someone left in between. Remya. Remya, can you hear me? Subramania.
Good morning, Chandra. Subramani Manigandan.
Yeah.
Can you hear me?
Yeah, I can hear you. Tell me, please.
I'm working as a lead engineer HCL Technologies. So
Okay.
I got the invitation from my colleague. Like even I have to know about the in-depth knowledge on VMware and HCL Technologies.
Okay.
So hope the session will be very helpful for me to do certification.
Okay, you are already working with the VMware segment. Is that right?
Yeah. Yeah.
Okay, fine. So let me start my session. So if this is actually a kind of introduction into data center virtualization, so data center in general, virtualization specific, and if you are keen to know, we can even discuss about the hyperconverged infrastructure. Anyway, I know that more people are actually there, but I couldn't actually just see all of them on my screen right now. No issues, and I can see that some of them don't have a mic also. So if you do me a favor, just drop in your introduction on the chat box. It will be helpful. Okay, maybe you are joining from other devices, which may not be that much interactive. So let me start. I think you can see my slide. Is that that's enough for us to just start the session? Can you, all of you, can you see my slide? Can someone just comment?
Yes, yeah.
Okay, so this is about a basic introduction about data center virtualization. Even before that, let me introduce myself. I am Shyam. I am into the IT infrastructure industry from almost 1998 onwards. Specifically started with my career in IT infrastructure with the kind of CompTIA, A+, N+, Server Plus level of skills. Moved to the MCSE, Cisco track, and from 2009 onwards, I am focusing on VMware data center virtualization. And from 2015 onwards, I'm specifically focusing on Nutanix hyperconvergent industry. And nowadays, I'm primarily a consultant as well as a trainer for this Nutanix technologies and doing a bit of VMware DCV also. One point of time, I am purely into VMware. Now it's a mix of VMware plus Nutanix. I do both the implementation for the customer side as well as the knowledge transfer for the same. So I'm okay with both the implementation part of it as well as the delivering part of it. So let us start with it. And I wish the session to be an interactive one rather than a kind of one-man show. It is just treated as a kind of casual session because we are only small number of people actually joining for this session. To be precise, for this evening, I have a much bigger audience, around 200 plus kind of thing. I don't know whether I can call it as a webinar or a kind of a broadcast, but this is going to be a pretty small group. So it's a good thing, actually. We can have more interaction between each other. You can ask your doubts. We can discuss it beyond the scope of what initially been discussed within your slides. Okay. And now I am just addressing the very basic person who is keen to know about the data center virtualization and who don't know anything about specifically about the virtualization. Okay, so that's why we are supposed to start this session. Hope you got the agenda. So we are starting with the very basic concept. I know some of you are actually technically fit to even start a discussion or just do a webinar like this one. But let me focus on the basic guys first, and we will move on. And maybe after 30 minutes, we can address your questions. We can be more interactive. Okay, so let me start. So to begin with, we will generally discuss about the evolution of data center. Sure enough, data center comes into play when people have their lot of compute requirements in place, and the computing requirements increase day by day. And we initially started, we all back from the 1950s or 1960s, we started from this kind of huge machines, which is a kind of number crunching machine, as well as the maybe it is so costly that only nations can afford it. We say maybe I'm looking at an IBM mainframe, this kind of a thing. So mainframe has its own advantages and disadvantages. The plus side, you are actually seeing it on the screen itself. It has its own kind of great kind of redundancy over there, great kind of protection over there. You can even partition the processor to different levels and run multiple processes at a single instance itself. And even the kind of the modern concept like the virtualization we are telling right now, that exists even at the times of mainframe computing itself. At that point, we never just specifically call it as a hypervisor or virtualization anything, but even that exists over there. So that is the very beginning point of your computing industry and the kind of normal level of data center. And naturally, the data center were actually this kind of a mainframe system where huge cost involved in it and lot of complexity involved in it. And at that point, if you're living at that point of a computing era, you will be using something like this one, like a dumb terminal to just connect it to this one, using a kind of, I don't know whether you just aware about it. Can someone just tell me what this one is, what it is? Your comments are appreciated. Any idea? Just to be part of interactive, can someone tell me what this one is all about? Or if you don't know that, you can even just turn on your mic and say, I don't know. Hello?
Sorry, I'm not sure about the exact name, but it's. I mean, I'm not sure about the exact name of this.
No issues, no issues. So basically, this is nothing but a voice coupler modem back at the time when we are actually going to use the dumb terminal to get connected to the mainframe. It is a pretty kind of a dinosaur kind of an age from the mainframe computing industry. And then comes something called, I will not take much time on that to be sure. So then comes something called a mini computing industry where the computer becomes a little bit smaller, can even fit into a room, but still more costly. And finally, we are pretty happy that the things were just finally hit your desktop. And if you are really passionate about your computing industry career, and maybe some of you already recognize this machine as a compact Proliant, maybe a kind of a server which exists on the 90s mostly, this kind of white machine. So nostalgic, right? So this is your server. So from the host terminal model of networking, we reached into a point where the client server networks actually came into place. And as your computing requirements actually increased, a typical kind of server rooms evolved. It is not in a position to even call it as a data center, but technically we can call it as a server room. And from this, all this chaos evolved a nice looking environment, what we normally call it as a data center. And people have a normal confusion regarding the data warehousing, data center, and so many other things related to the data center. So it is nothing to do primarily with the data. Sure enough, it has to do with the data, but data center doesn't have a direct one-to-one mapping with the terminology called data. So here the data center we means is an organized place where we are actually putting all those surveys, do a proper cabling, do their thermal management, do the intrusion detection. Everything will be taken care within this nice looking environment. What we call it as a data center. And if somebody really wish to call it as a server room, that's okay, pretty fine. If your company has a pretty small room where you are keeping your servers, you can call it as a server room. But data center has its own science attached to it, its own kind of technologies attached to it. And it's mostly the guys, maybe from the Snyder or other companies who come to your office and just do this data center implementation for you, right? As an IT infrastructure professional or a server management guy, I am not doing this. I don't know how to set up a raised floor architecture. I don't know even how to properly cable it. Maybe I know a little bit of it, but I don't care about actually doing this stuff because it's actually done by a person called the data center professional. And from my perspective, this kind of data center, the server is the most important aspect on it. So a bit of confusing thing when we are actually normally using the terminology called server. It can be many things. When you are saying a server, it can be many things. Like if somebody just asks me, what is a server? Maybe he has his own way of defining a server. If somebody is referring to a machine like I have a HP machine server with me or a Dell server with me, he may be referring to the hardware aspect of a server, right? So a server can be hardware, maybe much different from your normal desktop, more redundancy, more computing power, more capable of withstanding your 24/7 operations. So this is what I call it as a hardware server. A server can be hardware. And if somebody is saying that I have a Windows 10, 2012 machine with me, I have a 2016 server with me, or I have a Red Hat Linux server with me, he is referring to something called the NOS or the network operating system. So a server can be a software. A server can be a network operating system. And finally, if somebody just tell me that I am working in the web server segment, or I have an FTP server at home, I have a DHCP server, he may be referring to something called a service. So put it simply, so what is this one? What picture, this picture is all about? Can anybody just recognize this one, please? I get to know the first two picture. Who put the third picture over there? Can anybody help me to figure out what this picture is all about? Any help will be appreciated. No. Surprising? No issues. So it's an Apache Tomcat server, right? It's your web server, maybe just a logo of your famous Tomcat server from Apache Tomcat server. Anyway, so a server can be the hardware, the server can be your network operating system, or the server can be the services. But whenever me or we just discuss the concept called the server, I am referring to the hardware aspect of the server. And let us start with this hardware aspect itself. Because why? Because we are specifically discussing about the data center concept, and the hardware aspect of the server will be relevant to us. When we think about a normal server for most of your normal environments, this is the kind of machines that comes to my mind. It comes with a desktop form factor. Maybe it is cheaper to purchase, fine for your remote office, branch office environment, and I will call it as a desktop server. But the way which I'm just placing it, some people always call it as a tower server also. Doesn't matter. Whether you are actually keeping it in a flatbed or a tower form factor, doesn't matter. I prefer to call it as a desktop server. But I am not expecting a huge number of this kind of machines to occupy a single data center. If you just see the picture of that previous kind of stuff, that old data center or server room with so much chaos over there, I can see most of these machines are actually having this desktop form factor, right? When it comes to the case of the new age data center, this is the kind of machines that actually comes to my mind. And this one we normally call it as a, what do you call it as? Can you type in your chat box what this stuff is all about? Yep. Yes, please. I think just somebody just try to say something. Sorry. No issue. So this is called a rack mountable server, right? So why I am using this rack mountable server for my data center is just, it is so easy to just manage it on my data center. So most of these equipments over here, which I am seeing right now within my data center, is a rack mountable devices. It's easy to just place it in a rack. It is easy to just cable, and the thermal management functionalities will be just fine. So I'm using this kind of a machine on my rack. And what this is all about? Any clues? I'm all ears. I'm just trying to listen to you to get an answer for this one. Because we are having 10 people on board. Anybody, please? What you are looking at right now?
Stack of servers.
Look like a stack of server, and what do you call it as? I prefer to call it as a blade server. I know some people having a lot of confusion regarding blade server. I have heard it, especially the guys who is managing the IT will just say that, hey, this is my blade server. And I have to just say that, no, this is not a blade server. Like most of the people, some people, I will not say most of the people, but some people from the management aspect will say that a one new server, that thin kind of server will be called, they from their lexicon, they call it as the blade server. So just reiterate the point, this is the blade server, where we have a common chassis and we are plugging lot of servers into it, like this kind of things. This is called a blade, and I am putting a lot of blades into it. That makes it a blade chassis, whichever way you pronounce it, doesn't matter. That's an issue actually. Across the world, people pronounce this terminology in different way. Somebody will call it as a chassis, chassis. So nowadays, the industry avoid the confusion by using a terminology called a blade frame. That's it. So it's pronounced almost similar across the world. So it is called the blade frame. So now we have the desktop form factor, the rack mountable, and again the blade, which is also rack mountable, but we call it as the blade server, a kind of big one with lot of density, server density over there, managed by having a single kind of a power supply system and cooling solution. So this is a quick introduction about how your data center looks like. So I will take this moment to just collect any of your questions or any discussions you have on that quick concept of the physical data center concept. I just want to make sure that everybody will be in the same track about regarding their knowledge on those physical data center approach before we move into the virtual aspect. So that's why any questions on it will be appreciated. I'm waiting for 2 minutes. Nope. So I can. Oh, I sorry, I missed those chat actually. Subramaniam said that it's about the enclosure. Yep. Thank you. Sorry for missing your chat. And this is your existing data center. And we know that the companies are spending a lot of literally pouring a lot of money into this kind of data center infrastructure as part of their capital expenditure as well as the operational expenditure. So that means maybe millions are actually spent on setting up the data center, millions or maybe thousands are actually setting up, just paying the utility bill, maybe for the cooling solution, maybe for the power, and even just keeping that, feeding the IT administrators on those the floors actually. So the companies are spending a lot of money on this part of it, data center. And the question, why we need to just virtualize this kind of a concept, why we need the virtualization in the first place. So I am just giving a link, maybe a screenshot from a website actually, where the link is actually given below. They are saying that across the world, is back from the story from a website from 2016 actually. The world's data center, there are millions of data centers across the world right now, and it is actually consuming more electricity than the entire UK homes actually. So it's a huge figure actually, which contribute to the greenhouse effect, maybe the kind of energy crisis as well as environmental issues. So there are a lot of articles actually written over here about how to actually increase the efficiency of your data center without actually just utilizing that much electricity. Maybe we can switch to other alternate methods of using like solar, but still that comes with a carbon footprint for sure. So there are a lot of things that need to be discussed. But from my perspective, to be frank enough, I'm not concerned about that specific part of environmental aspect right now, because my duty as an IT administrator will be to just give you value for money for the company most of the time, rather than focusing on the environmental issue. Just sorry for saying it frankly, but that's how the industry thinks about it, even though you are put so much fashionable words into that. So why we need a virtualization? Because the very basic reason why we need a virtualization is how much computing power you are using from your, so you are spending so much on the servers, and how much you are getting as a return of investment in terms of computing power. According to one of the reports from the Gartner, they done a survey on it maybe a few years back, and they're saying that almost only 10% of that computing power is utilized across the world, and across 90%. Like, just like I'm using this laptop right now, if I'm running a performance monitor software on, which is actually comes part of my Windows itself, if I'm just opening the task manager and checking how much CPU, how much RAM is consumed at this point of time, I can always see that it's almost 5% or 10%. That's perfectly fine with my laptop, because that's my personal asset. I maybe use this laptop for a presentation of one at this point of time, and I may be using it for to do my video editing at a different point of time. So I don't care whether I waste this computing power or not. But about the servers, you actually spend millions for keeping it up and running. The company will surely ask for the return of investment. So if your boss find out, I think some of you are also boss also, I don't know, if your IT manager or your boss find out that, hey, you have 10 surveys over there, and if I check that, I can see that most of these surveys are only consuming 10% to 20% of the actual computing power. Why you just implemented so many surveys on your environment? Why couldn't you push most of this application to a single machine and that's it? Why couldn't you do that? So that kind of questions will normally arise from your management most of the time. So anyway, as an IT admin, I will say that I cannot do that, because I have a SQL server over here, I have an Oracle, I have an application server. These are different silos. I cannot put all this into a single basket and risk actually losing everything. It's the first thing. And maybe some of the applications may not go well with each other. Like my SQL and Oracle may not be good enough to work on a single computer itself. It has so much overlapping areas of interest. So it's not a good idea. If I am putting my AD as plus my SQL on a single box, and if for some maintenance I need to restart my Acropolis AD, it is not a good idea to just let down your SQL server also. So I need kind of partitioning, a kind of protection between each and every computer, still maintaining or maybe the value for money for that. So that's where this virtualization comes into the play. If you can see this stuff, it's about just creating a virtual version of anything. It can be computer hardware, which we are referring today for our session, or it can be a storage virtualization, it can be your desktop virtualization, it can be network virtualization, or it can be application virtualization. Virtualization is actually as part of every stack of your computer data center. For precisely with our case, which we are discussing about the data center virtualization, is the process of running a virtual instance of a computer system in a layer abstracted from the actual hardware. Don't care about this slide. I will be happy to share this slide after this session is over. I will drop it to you. No worries. I will rather drop it to Anand or anyone from Amstar, and they will just drop it to you. And anyway, since we just discussed about this virtualization, this is how your physical machine look like. Like I will say that these are the measurable parameters within your physical server. I can see that there are CPU, memory, your LAN card, and disk. And I know there are so many other things associated with your computer, but these are the measurable parameters within your computer. And what normally happens within your environment is that you are installing an operating system on top of this one, and you are running multiple applications. You may or may not run multiple applications on it. And the thing is that if somebody says that, hey, your machine is not 100% efficient, it is just utilizing only 20%, your normal urge is to install more application into it. And this application may crash into each other, or a lot of things, we need isolation between them. So this is a good idea to just run a software called a virtualization layer. I know we need to have a more detailed discussion about it, but since it's a pretty small time frame we are actually having, I'm making it a little bit faster. So we are going to install something called a layer called a virtualization layer. To be precise, this virtualization layer in generic terminology will be called a hypervisor. By the way, this terminology called hypervisor is maybe invented back in 1950s itself by a company called IBM as part of one of their mainframe computing concept called VMMMS, Virtual Machine Management System, which we are not talking right now. You can even Google for the Virtual Machine Management System. And they coined a terminology called the hypervisor, which comes as a generic terminology for this kind of any hypervisor. And your company may be using a different terminology for that, depends on which implementation you are having. Anyway, from the generic perspective, I will say it as a virtualization layer. On top of that, you are actually, virtualization layer is nothing but a custom designed operating system, specifically designed only for doing this virtualization task. So what this virtualization task is all about, it is about abstracting that 4 physical parameter called the CPU, memory, NIC, and disk, create a management layer on top of it, just create some task, which we normally call it as a virtual machines, and just give time slots or specific slots for running each and every process. So this is kind of a management concept and an abstraction concept. We call it as a virtualization layer, and we are running virtual machines on top of it. We will say n number of virtual machine, depends on the power of your underlying hardware. Maybe some of the hardware will be capable of running hundreds of virtual machines. Some may be doing maybe 10 virtual machine or 2, 3, depends. Anyway, I'm just showing 3 of them. N number, I will rather say. So each and every virtual machine can be treated as a process. And you are running your regular operating systems on top of it. And by the way, this operating system don't have a clue that it is running on a virtual platform. It looks down and think that, hey, I am having a real computer into which I am running. In reality, this operating system is communicating something called a virtual CPU, virtual kind of memory, virtual NIC, as well as the virtual storage. And in turn, the virtualization layer will schedule all these jobs back to this operating system. So the operating system don't have a clue that it is running on a virtual platform. And on top of those operating system, I am running my regular applications, and that's it. So each and every combination, like this virtual machine, OS, and application will create one isolated kind of a stuff. And it is actually independent of any other virtual machine running over there. And if your virtualization layer is smart enough to just partition each and every job to the specific kind of containers, that's perfect. That's the real quality of your virtualization layer. And there are many companies in the market which is providing the same. Some may be leader, some may be trailing behind. That primarily relates to the ability to just how good they are actually performing this kind of a scheduling for this environment. So that is the very basic concept regarding this virtualization. So this was your physical architecture where you have a regular x64 or any kind of architecture. On top of you are running the operating system and you are using the application software, then that's it. Now we have a more better method to just utilize the kind of 100% efficiency of your hardware for which you paid a lot of money. So virtualization is all about more efficiency for your computing and more about the management aspect of it. And I will personally say that it is more about the management aspect rather than the money you are saving from the virtualization. Technically, hey, you are also saving the money because previously, just if I need to design a physical infrastructure, I need to have 100 physical machines over here. On the same case, I can have maybe 4 or 5 physical hosts running hundreds of virtual machines on top of it. So that practically reduce the data center footprint to a great extent. So naturally, it reduces my air conditioning capacity to a great extent, reducing the energy power cost involved in it. And again, it is for management. Rather than racking, stacking, cabling each and every computer, I can use this device, my mouse, to spin up the computer in fraction of maybe minutes. I can spin up the computer and just move ahead with it. And this concept itself forms the very basic foundation of most of the cloud infrastructure you are spinning on your Amazon, on your Azure, any kind of platform. Behind the scene is nothing but the VM or the virtualization itself. Any cloud technology you are seeing right now is purely depending on the virtualization concept to make those management easier, automated, maybe programmatic, whatever you call it. And this is about a quick overview regarding this virtual infrastructure. Any specific questions, please, if you have? We are having more participants, I know, like this now 14 of you actually. I haven't introduced to each and everyone personally. As I mentioned, if you have anything to introduce about yourself, you can use the chat room to just type in there. And myself is Shyamlal for the new persons who came in late. Myself is Shyamlal. It's a seminar or a webinar on data center virtualization. Any questions, please? Okay, so I think we can continue. So this is about your virtual infrastructure, and you know there are a lot of difficulties associated with the physical infrastructure. When I started implementing and delivering the training for the virtualization, maybe back in 2009 or 2010, it is really hard to convince the people that hey, this is the real stuff, because what normally happens is that people will be skeptical to move to a new technology. How come a virtual computer can just replace a physical? I just need to touch my computer, I need to feel my computer, and somebody will walk into the data center, hey, ask, hey, where is my Oracle server or where is my SQL server? And I need to show them, hey, this is your computer, and they will be happy. But if you are just moving to the virtual platform, you have a computer and that's running hundreds of virtual machines, maybe 10, 20, or hundreds. And if somebody just asks me, where is my AD, where is my application server, I cannot show them. I can just open a console and just show them. And some of them may not be happy with those ideas of virtualizing their infrastructure. That is back in 2010 or 2012, I will say. Because at that moment of time, only 5 to 10% of your actual workload actually begin to virtualize. But now the story is altogether different. If I'm just thinking about a physical infrastructure, I will be really curious why they are still maintaining their infrastructure in physical. That's a bad idea from my perspective nowadays. So yeah, I do that work of P2P conversion even now, right now, mostly for the Middle East countries. Sometimes we have that assignment when we look into that, we say this old physical environment out there and they need to convert it. And they think that it is a new technology they are embracing actually. So now I know that it is a old technology which we are discussing right now, because virtualization itself was there even from the 1960s. Forget about that. It was there in 90s with the Microsoft NT virtual DOS machine. It was there with the Citrix kind of concept. It was there with the virtual PC concept of Microsoft. But it really got a boom when back in 1998, a company called VMware introduced a concept called the binary translation process of doing the virtualization. And they came up with their first product called the VMware Workstation, which is still a popular desktop-based virtualization solution for many, I know. And they just move ahead with making more corporate and enterprise-centric products like VMware GSX, and then with something called a VMware ESX, then with the really famous ESXi, which really sticks on even at this point of time. And their whole ecosystem nowadays, we call it as a vSphere environment. So that's where all the gameplay started. So that even from that perspective, I can say VMware is a 20-year-old company. So we are talking about a really old technology. If you are thinking about that, we are not discussing about a cutting edge or a breakthrough concept which evolved on the last year or so. So we are talking about an old technology. So this is the good thing about virtual machines. It's really, these are files, nothing but files. You can move it anywhere. You can just migrate your virtual machine from one physical host to another with a click of a button, and that's it. And if one of your hosts failed, all this virtual machine running on this physical machine can just fail over to another virtual machine with a matter of just kind of time you need to restart it. If you cannot even tolerate that time for restarting, you can do something called a fault tolerance process so that it will never be down. Okay, so a lot of management aspect, which is good thing associated with virtualization, that made virtualization really popular. And this was the previous environment where we used to have something we call it as a 3-tier model of your physical data center infrastructure. We do have servers, we do have the regular network as well as the storage networks, and we do have the centralized storage. We normally say it as a SAN or a NAS, which is connected to this physical service using a storage network. And you have another production network where all your clients and other equipments are actually being connected. And we typically call it as the 3-tier model of physical data center infrastructure. From that evolved the concept, again, the 3-tier model of the virtual infrastructure. Whenever we are normally talking about a legacy or a common kind of virtualized environment, you are referring to the 3-tier model of virtualized environment. There involved a number of machines which is running the virtualization software. We preferably call it as a host, on top of which we are running multiple VMs. And there are a storage network where you have a dedicated NAS SAN boxes over there, and you have a network which is actually connecting these stuffs together. So that's why your server or the host machines, your storage network, and the storage, we call it as a 3-tier model of networking. I'm sorry, the 3-tier model of virtualization. I'm just have a quick check on any chats or any questions over here. No. Okay. And we have, when we are thinking about virtualization, we have 2 types of virtualization. And we have something called a type 1 virtualization as well as type 2 kind of virtualization. Type 1 virtualization basically means you are installing your virtualization operating system or the virtualization software directly on top of the hardware, and on top of that you are creating the virtual machines. So the common example for is the VMware ESXi or your Linux kernel virtual machine, or the Hyper-V core operating system, which you are normally installing on your physical hardware and running the computer on top of it. And the second method is something called a hosted kind of virtualization. So that practically means you already install a regular operating system. Just like my case, I have a Windows 10 on this laptop, And if I install a software called VMware Workstation on top of it, it's called a hosted virtualization. So that means we have a physical machine with a regular operating system. On top of it, you install a virtualization software, and inside it you are creating a virtual machine. So that mostly done for maybe academic purpose, mostly done for your test environments, mostly because the bare metal actually gives you more flexibility and more utilization of 100% utilization of all the resources, because there is no extra layer of operating system in between. That's how it works. So we have a type 1 virtualization as well as a type 2 virtualization, where I will say that the type 1 is the most popular model of virtualization solution. Even the company called VMware started with the type 2 virtualization itself on their portfolio. And after that, they actually moved with the type 1 virtualization. Now they are sticking on to the type 1 virtualization. And this is how this your regular total virtualized environment look like. I'm not sure whether I need to actually go in depth into it, because I didn't actually get a proper specific answer from your team members right now. And let me check after just having a kind of a demo or something. I will come back to this slide and trying to explain this. It's a boring theory behind it. Okay, so anyway, we will come to that. Uh, let me just open a whiteboard session, so that if you have any discussions actually coming up, I will be happy to just do that. Any questions or anything, it will be appreciated. I'll start from a new whiteboard, and after that we will just specifically start looking at some various companies or products. And to begin with, I will say that whenever I'm thinking about virtualization, for the very first thing, it will be something like the VMware, because they started this the new age kind of virtualization. I will not say that the virtualization is a concept invented by VMware, but the virtualization as we seen it, the desktop virtualization made popular by a company called VMware and their ecosystem of a product called the vSphere. And naturally, the Microsoft followed the path. After VMware came to the market back in 1998, Microsoft have a competing product back in 2008 with a product called the Hyper-V for the 2008. That is a product actually came as a direct competitor to VMware at that point of time. But I will not say that that's a direct competitor, because that's not at all a real product to just even compete with VMware at that point of time. But with 2012 Hyper-V, VMware got a real nice competitor. So we have that. If you check the Gartner report for this virtualization, we can see that Microsoft and the VMware is the two leading players as far as this that server virtualization market is concerned. Then a lot of players came into that. One of the major player is actually the Red Hat with their kernel virtual machine aspect at that point of time. At that specific point of time, the KVM, the Red Hat KVM was there to just compete with the virtualization industry. And Citrix, a long-time player on this segment, actually came up with their product called the Zen server. So we have the Citrix Zen server, the Red Hat KVM, VMware, the ESXi solution, and this Hyper-V solution that actually having. It's actually, I'm just talking about an old story. Now the Zen is actually not that much popular. KVM is not at all that much popular when you think about the virtualization. And a new player, which is actually the same KVM itself, has been reincarnated into a product called Acropolis Hypervisor, or the AHV, which is actually running on your Nutanix boxes right now. So that's actually also offering a serious competition to the other companies also. That's a quick discussion about the other products or other solutions as we are saying right now. And finally, let me check. I have a like when I just it's my training room actually. I have a pretty small implementation of it. Let me show you that. I think you can see that. If you are checking it close enough, we can see that this that yellow and ash color looking machine which you are seeing right now is one of my server which is running a hypervisor called VMware ESXi. And yes, please. Let me check what's the IP address of it so that I can show you a glimpse. Okay, I can see that IP address. Let me type into my screen. Yep, it's this is the interface for my VMware environment. It is running a VMware the vSphere environment version 6.7, which is the normal production 7 version, which I know that the 7.0 also came, but this is the production one. Let me type in my username and password to directly enter into my VMware ESXi host. And as you can see there, I am actually currently running 2 virtual machines also over there, where this is actually one of my virtual machine, which is a 2012 server, and I have another 2016 server also. The real good thing is that I can really manage it really fast enough. I can create a snapshots, revert back to the snapshots. I can just clone it. I can do vMotion to a different host. Whatever thing I require, I can do that. So that's how we are actually normally performing it. So this is about a quick overview regarding this, technically about this concept of virtualization. And sure enough, when you're thinking about virtualization in a big way, the other concept that came into the market, swiping the very basic foundation of the virtualization, is something called container concept. So one of the premium example you can check is actually the Docker container. It's actually, when you are thinking about virtualization, it is about, like, if I'm just trying to compare and contrast, this is how your regular virtual infrastructure look like, which we just discussed right now: the infrastructure, the hypervisor, and your operating system with the application running on it. Containerization is a different approach, where you have something called a Docker container, which is actually each and every apps are actually acting as a container. In one sense, it will take you back to that old days of regular computing itself, but this is a new incarnation of that concept, and it is actually a self-contained package. Each and every container is a self-contained package of application that specifically run. Many of the applications which you are seeing right now for your day-to-day environment, like when you are booking a ticket through, what is that? Ticket booking, the film booking application which we all use actually. What's that? Find my ticket. Oh, I just forget that. Anyway, those kind of stuffs are actually working on this Docker containers. That good thing is that when real requirement comes in, you can just scale it out so fast. So it's a new kind of thing you need to just look into if you are thinking about moving your career further into the virtualization market. And there comes another concept called the hyperconvergence, which which blend the concept of the 3-tier architecture into a single box. So rather than having a different storage box, a storage network, and the kind of physical host for the virtualized servers, we can have a single box where all your storage, virtualization, and the virtual networking, every aspect can be rolled into one aspect. And one of the leading company for the same is Nutanix. Sure enough, VMware has their own solutions like the vSAN, the VxRail solutions, and so forth on that. But still, Nutanix is the industry leader as far as this hyper-converged industry is concerned. Okay, it's just a kind of quick, high-level 1,000-foot overview regarding this your virtualization concepts. And we are almost done with this introduction to the hyperconvergence, virtualization, and container part of it. So that's for my session as of now. Now you are actually, if you just become interactive and you have any specific questions, you can actually ask it right now on your chat box or a voice. And after a while, maybe within 10 minutes, our session will finish. And if you have more things to ask, we can spend more time, no issues. It's time for our discussions. If you have any specific discussion points, feel free to shout.
Thank you so much, Mr. Shamlal, for the nice intro and details about data center virtualization. And I think it was a really good session, and people must have liked it. So, dear participants, you may please raise your questions if you have anything.
Thanks, Shamlal. I'm Ratish here.
Yeah.
Thanks for your session. I have to drop off from this meeting. I have another meeting scheduled.
No, it's not.
And I appreciate your time.
Thank you.
Thanks for all your support. Thank you. Cheers.
Thank you.
All right. All right. So I think then we shall conclude the session, sir. So I think participants having any questions, do feel free to write to us, and we shall certainly connect you with Mr. Shamlal to answer your questions. And once again, thank you so much for joining our today's webinar, and we look forward to connecting with you again in near future. So have a nice day, and thank you so much, Mr. Shamlal, once again for your session.
You're welcome.
And thanks a lot for your time, and we will be in touch, and we will keep you posted about any questions if arises from the participants.
Yes. Sure. Thank you. Bye.
Okay. Good day. Bye bye. Good day.
Bye.